In this video, we will learn how to solve a constraint optimization problem using Lagrangian approach. The question I have cut it short because of the lack of the space. The question says we are being given a production function, that is Q is a function, that is output is a function of two inputs x and y, which is equal to natural log of x square plus natural log of 4 times x times y plus natural log of y square. Price of input x is $1, price of input y is $1, and total cost incurred on the production of x and y. Cost incurred on the inputs is $50. We have to find out the optimal values of x, y, and lambda, and interpret the meaning of the lambda, the value of the lambda that we will get using Lagrangian approach. Okay. So what is our endeavor here? We want to maximize the given production function, that is Q is equal to ln of x square plus, let me write it like this, ln of y square, then plus, then I will write ln of 4xy. okay. Our endeavor is, so graphically what exactly is meant by this? We are being given x and y are the two inputs with the given production ISO count. So we have this production ISO count. Rather, let me first rub this out. Good. Okay, so we want to maximize this ISO count subject to the constraint that we are facing. That is, our constraint will be price of x times the units of x employed plus price of the input y times units of input y employed should be equal to the total cost, which is equal to 50 here. Okay, so price of x is 1, that is being given, times x, so 1 into x, so we have 1 into x plus 1 into y is equal to total cost is 50. So our budget constraint will be x plus y is equal to 50. Okay, so let me rub this. So graphically, what is our endeavor? With the given budget, let me draw the budget line. Okay, the firm wants us to produce maximum output. So with the given budget, producers' endeavor will be to reach to the highest possible ISO count. So our optimal bundle will lie at a point where slope of this ISO cost line is equal to the slope of the ISO count line. Okay, ISO count curve rather. But we have to solve the given question using Lagrangian approach. So in the Lagrangian approach, what we do, first thing is we set the given budget constraint equal to 0. So first step is, if I set it equal to 0, I will get 50 minus x minus y is equal to 0. Okay, first step is this. Second step is to multiply the given this resulting constraint by lambda on both sides, and third step is to form the Lagrangian function, that is L will be equal to, that will be equal to the given production function, what we call the objective function, that is, let me use the proper color ताकि तो ये पूरा है. So ln of x square plus ln of y square plus ln of 4xy yatlej khai go dafa. Okay, so Lagrangian function is formed by adding the objective function and the resulting constraint that we have constructed. So then we have 50 minus x minus y. This is our Lagrangian function. Now to find out the optimal value of input x, y, and to find out the value of this lambda, what we do, we partially differentiate this Lagrangian function with respect to x, y, and lambda simultaneously and set them equal to 0. Okay, so first step is, what will we do? We partially differentiate ln of this Lagrangian function with respect to x. Okay, now let me do the partial differentiation here. What is the derivative of ln of x square with respect to x? So first, the derivative of ln of x square will be 1 upon x square. Then by chain rule, the derivative of x square is 2x. Okay, so I will get here x and x will get cancelled, so we will get 2 upon x. Derivative of ln of y square will be 0 because we are taking partials with respect to x. Okay, now the derivative of this ln of 4xy with respect to x, okay, will be equal to, so first the derivative of log function, we know it is 1 upon 4xy times the partial derivative of the denominator with respect to x. Derivative of x is 1, so we are left with 4y. 4 gets cancelled, y gets cancelled, so we are left with 1 upon x. Okay, so we get here 1 upon x. Now the derivative in the last, derivative of constant is 0, derivative of x will be 1, so we are left with minus 1 into lambda is minus lambda, and we set it equal to 0. Okay, first thing, symmetrically, I hope I am doing it correctly, in this correct way. So ln of y, similarly we take the derivative with respect to y this time. So derivative of ln of x square will be 0 because we are taking partials with respect to y. Ln of y square will be equal to, so the derivative of log of y square will be 1 upon y square times the derivative of y square, that is 2y. So y and y gets cancelled, we are left with 2 upon y, plus similarly we have ln of 4xy, its derivative with respect to y this time will be, so first the derivative of ln of this stuff will be 1 upon 4xy times the derivative of this function with respect to y, so we are left with 4x, x gets cancelled, 4 to 4 cancel, at we have 1 upon y, minus derivative of y will be 1, so we are left with minus 1 into lambda is minus lambda, and we set it equal to 0. Symmetrically we take ln of lambda will be equal to, so take the derivative with respect to lambda partially. So since no lambda is involved in the first 3 terms, its derivative is obviously 0, so the derivative of lambda is 1, we are left with 50 minus x minus y is equal to 0. Okay, I hope I am making myself clear. Having said that, let me save the space here. So if it is equal to 0, okay, so can I write it like this? If I transpose it here, it will become plus lambda. So let me use plus sign here, okay. So let us say this is equation first, this is equation second, this is equation third, dividing 1 by 2. Or if I further solve here, so we have same denominator, so 2 plus 1 is 3 upon x. 3 upon x is equal to lambda. Here it implies 3 upon y is equal to lambda. Dividing equation 1 by 2. So dividing equation 1 by 2, what will we get? We get 3 upon x divided by 3 upon y is equal to lambda upon lambda go lambda. So we get 3 upon x, transpose it to the numerator, it gets multiplied but reciprocated, so we get y upon 3 to 3 go cancel is equal to 1, so we get y upon x is equal to 1, which implies y is equal to x. Okay, now we have the options. We plug the value of y is equal to x either in the third equation or in the given budget constant that we have in this equation. So it will be easier to put the value here to get the value of x and y. So since y is equal to x, can I write x plus in place of y, which is equal to x again, is equal to 50. So 2x is equal to 50. 2x is equal to 50, which implies dividing both sides by 2. So x will be equal to 25. Plug again the value of, since y is equal to x, that means y is also equal to 25. That means the optimal values of x and y will be 25 and 25. Okay. Having said that, nevertheless, what is the value of lambda? Now plug the value of x is equal to 25 y is equal to 25 in either of the first two equations, either here or here. Okay, so let us plug the value of x is equal to 25 here. So we will get 3 upon 25 is equal to lambda. So the value of lambda is equal to 3 upon 25. So 3 upon 25 क्या go? 3 upon 25. Okay, so we have 3 25 point ये को 0 25 ones are 25 ये फिर सर हमें 5 25. Okay, so 25 twos are, so we got 0.12. So the value of lambda is equal to 0.12. So what exactly is meant by this? The value of lambda simply tells us how much our output will increase when there is change in the constant of the constraint function. Okay, how our objective function will change when there is change in the constant of the constraint function. So constraint function is, so what is the constant in the constraint function? That is this cost function. It simply tells us how much our production will increase when there is incremental increase in the cost. It says simply what happens to the production when the cost increases by $1. Okay, so lambda is equal to 0.12 simply tells us when cost, in this case, increases by 1, when total cost increases by $1, that means output will increase by $0.12. I hope this is the interpretation of the lambda. It simply tells us how will our objective function change when there is change in the constant of the constraint function. So constraint function is this. Okay, budget, here we have the budget constant, obviously. I hope I make myself clear and I made the justification to the explanation that I gave to you. So this question was asked by a friend on the Telegram channel of Econ Maths, so I thought I should help it now. So you know, I make these videos free of cost, so my only what I can say, my only endeavor is to help you people. I don't charge a single penny for these videos, so my only motivation will be if you like, comment and share this channel with your friends. Okay, thank you.